Now, so that is some of the things that you can do without going into more hardcore graphics. All the previous things that you have seen, you have done a little bit of graphics kind of things, but without actually making use of graphics. I mean hardcore graphics, as in terms of drawing things directly on the screen and so on. But there are certain things, certain places where you really have to draw things onto the screen. And in those circumstances, then you do 2D graphics with canvas. I will show you a couple of examples of these also to illustrate to you how you can implement simple games using 2D graphics with a canvas. And then we will briefly review 3D graphics later on. So, 2D graphics with canvas is more suited for applications which require a lot more control over what is drawn on the screen. You want to be able to create specialized effects on the screen and so on. So this would require specialized drawing or control of the animation of the graphics. Then 2D graphics is more appropriate. Now for doing this, we use something called a canvas. What is a canvas? Canvas is nothing but a representation of the screen. Just like when you draw pictures, when you draw diagrams, when you do art, you know, like in your grade school, primary school, you have done art, right? And so what do? You take a piece of canvas and then you draw on it with your crayons or paintbrush and things like that. Same kind of effect here. You are given a piece of canvas. You are asked to draw everything on the canvas. And after you finish drawing onto the canvas, then you throw it onto the screen. And then it is displayed on the screen. And if you want to make a change, you again redraw on the canvas and then again throw a new copy onto the screen, and the old one gets replaced. So if you need to create animation, you can throw a sequence of slightly modified version of things, like the way you do cartoons. Right? In cartoons, what is cartoons? Cartoons is nothing but a sequence of frames. So a frame is like one drawing on a canvas, throw it onto the screen, replace it after a short while. What is the minimum rate at which you need to replace things on the screen so that the human eye sees it continuously?
50.
Sorry?
50.
No.
No.
Human eye can detect things about 30 milliseconds apart. If there is more than 30 frames per second, which is approximately translates into 33.3 milliseconds. 30 frames per second. If you display consecutively frames at the rate of 30 frames per second, then the human eye really cannot distinguish. I mean, it will see it as a continuous motion. All your movies and video and all that works on that principle. So that's basically what you're doing even with your games. You're drawing a picture, putting it onto the screen, and then replacing the picture within 30 milliseconds, within 33.3 milliseconds. Then you draw the next version, throw it onto the screen within 33. So if you want to show a football moving on the screen, you draw the first frame with the football at one location, then within about 33 milliseconds, replace that with another frame where the football is slightly moved from the previous version, and so on. If you consecutively draw things, then you will see it as a motion on the screen. That is basically what 2D graphics is all about. Okay? So, how do we achieve this in practice? So, in Android, you're given access to this thing, this object called this canvas. And onto the canvas, you draw things like circles, lines, rectangles, text, dots, whatever you want. And as long as you have created the frame, once you have drawn whatever you want and you're happy, then you throw it onto the screen. That's basically what you're doing. So you are drawn to a bitmap which is placed. I'm mixing up too many things. You are drawn to a bitmap which is placed on the window, on the screen. So that's basically what you're doing. So this canvas class allows you to draw a lot of things. Draw a lot of things using these methods called draw bitmap, draw rectangle, draw text, and so on. Draw oval, all these things. And so you basically call them in order to create those things onto the canvas. And then once you have drawn your screen, then you do the display. For applications that do not require significant amount of processing or frame rate speed, you can do this directly using view animation. Okay? Sorry, not what I should say. You can use a custom view component, which I will show you how to do. And then when you create a custom view component, this component will give you a canvas, and then you can access the canvas by using this method called as view.onDraw. OnDraw is a method that is available in the view class. Okay? And SurfaceView is a more generic version. SurfaceView is a subclass of view, and it allows you to do provides you with a dedicated drawing surface within the view hierarchy. SurfaceView is a bit more complicated to handle than simple view, because it requires you to implement certain handling classes and so on, which I will come to in a short while. I'll show you an example of implementation of that in a short while. Okay? Now, with a view, how exactly do you achieve 2D canvas drawing with a view? For this, you basically extend the view class. And once you extend the view, how do you extend a view class? You define a class which is an extension of the view class. The class with a name extends view. And then after you do that, inside that extension, you'll automatically get this onDraw method. And inside the onDraw method, you draw things onto the screen. So you use the onDraw method to perform all calls to draw on the canvas. So in this case, for the view class, you don't need to explicitly access the canvas. Instead, whatever drawing you need to do, you can include all those calls in this method called as onDraw, and that will allow you to draw things onto the screen. And then, once you are finished drawing, okay, then you call this method called as invalidate. When you call this method called as invalidate, what this will cause is it will cause the Android framework to call back your onDraw method. So if you do invalidate inside your class somewhere, it will force the Android framework to call your onDraw method. When the Android framework calls your onDraw method, you will be again redrawing the next version of the screen. And then the moment you call invalidate, you will be refreshing the screen again and then forcing it to call your onDraw method all over again. So you basically trigger consecutive calls to your onDraw in order to display consecutive screens. Okay? Again, this will become a bit more clear when I show you an example. So inside your views onDraw method, you use the canvas. The canvas is already given to you in the view when you access it inside the onDraw method. You don't need to do anything specifically for the purpose. And then you can draw things like canvas.draw and all the methods that you can invoke on the canvas. Okay? And once you're done, then you invalidate, and then when you do invalidate, Android framework will call your onDraw again, and then it will paint the screen with the new picture. Now, this seems confusing, so what I will do is I will show you some code to show you how I do this. So before I show you the code, I will show you a simple example of the use of onDraw method. Does it help if I keep switching between the code and the explanation? Because sometimes the notes is very dry.
Yeah.
And if I even I understand. Yeah, even I understand. That's fine. But if I throw in all the code onto the notes, it will be reproducing everything that I have already done. So instead, I will point out where the code is, so you can read the code with the background that I explained in the class. So let me go back to the example, and this one is called as a ball game. This is a game you might have played around with in your childhood somewhere. or you might have seen a version of it if you had one of those video gaming systems somewhere. So I tried to recreate one of those simple games that you used to play during childhood. So this game, basically this is a ball moving, and then I have this paddle here with which I need to bounce the ball back. You have all seen a game like this before, have you? Now, obviously, this is not. If I don't do anything, the ball will disappear and then the new ball will appear from the top. So in order to move this ball, see, when it hits the paddle, it bounces out. Now, if I want to, I can move this paddle to the right and to the left by using these arrows. Okay? So if I am every time the ball goes away, disappears, I will deduct the score by 1 point. Okay? Now, let me see. I am very poor at playing games. If you play it on a real phone, it's a bit more fun too. There you go. And every time you bounce the ball back, your score is deducted by is incremented by 1. There you go. See, you can have fun in the course too. You can spend hours together, but please don't waste your time. I can stop the game by clicking this middle button. Of course, in a real phone, you don't have those buttons. But if your phone has those buttons, then you can do this. What I did was I implemented this, and then later on I'll show you how to make use of the sensors of your phone in order to control this game. So I can tilt my phone like this and then play the game. Okay. Later on I'll give you that version of the game. That is a bit more interesting than this one. Okay? Now, if I stop, then I can increase the speed of the game. If you want more challenge, if you click.
Whoa.
It's too fast.
Whoa.
So if I do this, I can decrease the speed of the game.
I think it's difficulty, right?
You're changing gravity.
Yeah.
Oh, I don't remember what this one does. I think it increases the
Difficulty, right?
2 velocities of the thing and so on. I thought it was decreasing the velocity, something like that.
Well,
Well, anyway, you can have some fun with the game. Now, if you're wondering, how did I implement this game? It is very simple, actually. I'm not very good at programming large systems, so I implemented a small thing. So, how do you do this in practice? Okay, let me stop this, and then we will move on to look at the game itself. So what I do is I declare this layout first point to start. I declare this layout called as main.xml. Okay. Inside this layout, notice that I have a component that I have declared. A view that I have declared like that. This is a custom view. I built this view myself. Okay? This custom view is built by implementing this drawView class, which is a subclass version of the view class. Okay? And I access that by saying hkust dot. This is my package name. And dot this class. So I should have a drawView class, which is a subclass version of the view class that I have to declare somewhere. So you would obviously expect a drawView.java in my code. Okay? So I do that in here. So this view is basically occupying my whole screen. That's why I say fill payment on the width of the height. It's occupying the complete screen. Okay? So this is the drawView class that I declare. Now, going back to the code, how do I make use of this in the main.java? This is the main file. which starts the game. So in the main.java, what I am doing is I am saying set content view r layout main. This you have seen before. So this is main.xml file being inflated, and I get a handle to the draw view that is declared there. That's it. Nothing more. This is the main class. One additional thing that I do is I say request window feature no title. So I remove the title on the screen so that I can use the complete screen for my game. So if you want to use the complete screen for your game, this is one thing that you can make use of. Okay? This is the main. The major action of this particular project is in the drawView class, which is declared in the drawview.java file. This file, drawview.java file. Okay, in the drawview.java file, what am I doing? I am extending the view class, just as I mentioned. So this is one way of implementing graphics. You can extend the view class. When you extend the view class, inside this is the constructor of my class. Okay? Straightforward to see, constructor. And then I declare a ball, a bounding box, and a paddle. This paddle is the red thing at the bottom. And I declare those. These three are three separate classes that I'm making use of. Four classes: ball, box, paddle, and status message. I declare them as four separate classes with their own properties, and so that I can manipulate the properties very easily. So I want to make my ball move. I say ball not move, and then the ball will move. Okay. Now, what do I do here? Inside my constructor class, I set focusable and request focus. This I need to do in order to get the focus onto that particular view. Then after that, I create a box, and box of this background color. This is the box that will occupy the entire screen, and it defines the boundaries within which my ball will move. Okay, so that's the reason for declaring the box. This is a paddle. I declare a red paddle at the bottom for me to move, and then inside there I specify, inside the paddle class, I specify the size of the paddle. I can increase and decrease the size of the paddle if I want. This is the ball. I create a ball. And then I create a status message which allows me to display things on the screen, like the current score of the user. So I have declared these four. All right, this is straightforward. This is the constructor class. Okay? Now, I will explain this in a bit more detail, but the other version I don't need to explain in this much of detail. Now, together with this, as I told you, if you need to manipulate anything on the screen, I'm going to go and implement this method called as the onDraw method. Inside the onDraw method, I am getting a pointer to the canvas whenever I call the onDraw method. Now, who is going to call the onDraw method? The Android framework. When is the Android framework going to call the onDraw method? Whenever I call invalidate, it's going to call the Android framework. So within the onDraw method, what am I doing? I am setting the, let me start at this point. I am setting the canvas's color. But unfortunately, what happens is that you don't see the white color because I superimpose a box on top of it with a different color, so that is hidden. Onto the canvas, I draw the box. Box.draw canvas. I draw the box. Then I draw the paddle, which is the red thing at the bottom. Then I draw the ball's location, current location. Then I write the status message onto it. So these four things I am drawing onto the canvas. I'm basically putting them onto the canvas. After I do that, I move my ball. So my ball is already positioned. I have already drawn the position of the ball using this. Then after I do that, I move ball. So next time I call this, the effect of this will be seen on the screen. So when I move my ball, I have to move my ball a little bit to the side. And so this is what causes the movement of the ball on the screen. So every time I move the ball a little bit. So how do you move the ball? Check this method of the ball to understand how the ball is moved. We'll come to check that in a minute. Status message, update the status message. And then after I do that, I create a thread and make it sleep for 30 seconds. Okay? Why? Because I need to update the screen every 33.3 milliseconds. Yeah?
But what if your drawing method takes like 15 milliseconds?
Yes. In that case, this is not the way to do it. You'll have to use the other one called the SurfaceView. In this particular case, since this is fairly straightforward, you can rely upon this method to do it. Okay? But if you need to do a lot of things here, like for example, if you're implementing a very complex game, obviously you need to update a lot of things on the screen. This is not the way to do it. You will use SurfaceView, which I'll come to in the next version. Okay? SurfaceView is a bit more complicated than this, so that's why I postponed it to the next version. So after I do the updates, I sleep for 30 milliseconds, and then I call this invalidate. Now, by calling this invalidate, what is happening is I am triggering the Android framework to call the onDraw next time. Okay? But the moment I call invalidate, whatever changes I have made will be painted onto the screen. So the moment I call invalidate, whatever is on the canvas will be put onto the screen, and then the Android framework will again call the onDraw method one more time. So when it calls the onDraw method one more time, I would have made changes to the screen. And then I will again, at the end, I will call invalidate. That would trigger an update of the screen. And then again, it will result in a call to the. So I am basically making it call itself over and over again. So that's the reason why you can see the animation on the screen. If I did not do this invalidate here, but instead I did it elsewhere, it would have done the change only once and then simply drawn it on the screen and then done. If I don't call invalidate, I won't be able to update the screen. As simple as that. Okay? If I want the screen to be drawn only once, I will call the invalidate somewhere else. But this approach is basically triggering a call to the invalidate every time the onDraw is being called, and that is basically causing my screen to be updated every approximately 30 milliseconds. Yeah?
Well, since it will automatically just go back and just trigger it again, so
yes.
How can you know when you need to stop? Or maybe if you want to stop.
Yeah, if you want to stop, then you have to find a method of stopping. Okay? Right now, I haven't implemented how to stop the game. Once it starts, it just keeps going. I have to hit the home button in order to get it off. But, I mean, as I told you, my code is not complete. So I don't handle all those scenarios, things like how do you stop the game and so on. But you can do things. You can stop the game and so on. In the other version, I have a little bit of suggested method of stopping the game. So, but in this particular version, I don't have that. Okay? And this one, this method on size changed, this method will be called whenever the view is first created, and every time there is a change in the size of the view, this method will be called. And this basically will tell me the size of the screen. So for example, if I'm playing the game and I suddenly tilt the, no, actually I don't allow it in this particular game because I set the orientation to be always portrait. So even if I tilt the phone, it won't tilt the game. So I don't allow that to happen. How do I do that? That I can do by going into the manifest file And then in the manifest file, I can simply state Android screen orientation portrait, meaning that the screen orientation is stuck in portrait mode. I cannot change it to landscape mode. Okay? Again, little details here and there, which you might miss out on. I show it to you here. It will be in the document for the lab that you see. But again, as I told you, do it in order to understand how it is done. Okay? So this is the draw view. So everybody understands how I'm making use of the onDraw method here for the graphics. So in case you're doing a graphics-based game, this is one method of implementing. But again, this won't do too many updates to the screens. If you have complex updates to be done on the screen, this is not the way. Simple things, yes, can be done. Fairly straight. And at the bottom here, I implement the handler for the key presses, all the different key presses that I do. So depending on which key I pressed, on key up, this is the on key up handle that I am implementing, on key up. If it is the right one, you move the paddle to the right, so it says paddle move right. If the key code be left, if I press the left button on the pad, then it will move the paddle. So that is why it is. When I press those two keys, I am able to move the paddle on the screen. So these two methods are the ones that are handling that. This allows me to increase the speed of the ball. This allows me to decrease the speed of the ball. So the up button increases the speed, the down button decreases the speed of the ball. The speed is specified in 2 dimensions. This is 2D graphics, right? So you have an X and a Y dimension. So you need to specify the speed of the ball both in X and Y dimension. So both speeds have to be changed. And then if I press the center button on the keypad, then the speed is set to 0. So that's why the frame freezes at the point.
But this will only work with a pad.
With a pad, yes. Yes, no question. Now, if you want to do that using a separate way, you can implement that. You can virtually implement a keypad on the screen.
Oh.
You can use buttons, up, down, left, right buttons, and then cut a portion of the screen and then use that as. I don't do that because in this particular case I'm able to use it. But you can create different buttons, up button, down button. You can even implement even more complex, controlling things using touch. For example, I can do that, and then we'll increase the speed of the ball, and then I can move my paddle left and right by using my finger. You can do that. I have not been that fancy. I have just used the keypad, but that I leave it as an exercise for you. If you want, you can test out those things and then see how it works. All right. Now, the important parts, or rather, the parts where I actually represent the items on the screen. This is the ball class. This is the ball class. So I basically represent the ball's radius here, and what is this? The center, X and Y, the center of the ball. The initial speed is 5 and 3. You can change those values and see how the game behaves. You can change those initial values and see how the game behaves. Okay? And inside here, I declare the ball, and then for any time you need to paint something on the screen, you need to get hold of something called the paint. You need to create a paint subclass, a paint object. So you create that by paint, and then this, if you manipulate the values of that, then it will allow me to change different parts of that. What is paint? Paint is an object of the class paint, and that paint allows me to change the color of the ball that is being created on the screen. So that's why when I create a ball, I can specify the color of the ball that I want to create on the screen. Okay? Now, how do I move my ball? This is where I implement the movement of the ball. So what I do is, I simply, every time I say move ball, I simply displace the ball in X and Y direction by the speed vector. And then when the ball hits, see, when the ball hits the boundary, the ball needs to reverse the direction. How do you reverse the direction of the ball? Change the speed value to negative of that. So if speed x is positive, when the ball hits the wall on the other side, change the speed value to negative, and then the ball will start moving in the other direction. Change the ball speed. Similarly, bottom and top. So that's what I do. You detect a collision to the four walls of the box, and then you simply change the. There are some minor things that I check in order to see where I hit the ball and so on. I make sure that the ball hits the wall, and the ball is still at a distance of 1 radius between the ball and the wall. And if it is within the radius of the 1 radius, that means I have hit the wall, and then I have to change the direction of the ball and so on. So some minor things that I do here. It's not complicated. This is the physics of the game. In general, if you have a very complicated game, you will have a method called update physics. So in there, you specify the physics of the game. Like, for example, if you're implementing a cannon shooter, right? You know what a cannon is, right? Cannonball is shot. If a cannonball is shot, what happens? From your high school physics, what do you know? If the ball is shot up into the air, it is given a velocity in the x and y direction. But as the ball moves, half gt squared. Gravity is pulling it down. So the ball has to take that parabolic path. That is physics. Physics of the movement. That's why in games you always implement a method called update physics. Basically, that is what calculates the physics of the game. You have an impact on an item and you need to bounce back. How do you bounce back? If the item is say a hard object, if you want to implement the item as a hard object, then a collision will cause the object to break. Right? You have to implement. The moment you detect the collision, you will have to paint on the screen fragments of the object in consecutive frames, and so that's how you display the object breaking apart. If you want to create a collision and then an explosion, for example, if a grenade hits the wall, you see the grenade, you have to keep testing until the grenade, the moment the grenade hits the wall, you simply draw an explosion flame on the screen, and then in the next couple of frames you keep it there, and then after 2 or 3 frames the explosion disappears, and then you can draw some smoke on the screen and then let the smoke disappear and then gone. So now when you play games, you realize how all these things are created on the screen. Okay? Again, I am no game programming expert. I have figured this out just by thinking about how I could do it. Okay? You might have a much better way of doing these things. Okay? So don't rely on my explanation for how to create games and so on. There are many examples out there, so you should consult them to find out how things are done. If you want to implement bouncing off of a soft object like a paddle and things like that, I have shown you an example. How does that happen? So where do I test? Okay, in here I test whether I hit the paddle or not. If I hit the paddle is at the bottom, right? So my y speed along the y-axis needs to be reversed, and that's what I do here. But if the item hits the box at the bottom and then goes down through the thing, I'll make the ball disappear, and then a new ball will appear at the top and so on. So some of those things I have implemented here in this particular case. Okay. Now, this method is the one that draws the ball onto the screen. So how does it draw the ball onto the screen? It says, canvas, draw oval, bounds, paint. What is this paint? Paint is the paint that you saw there, and paint's color is set there. And then the bounds tells me the position of the 4 points of the oval, and so that allows me to draw that oval onto the screen.
Where is bounds defined?
Bounds should be, let me see, here. That's a new rectangle. Okay. That's how I
Like
do it.
floating point?
Again, as I told you, this is just an example. You don't have to rely upon this as the method of doing it. It is just my way of implementing. You might have a better way of doing things. Now, how do I implement my paddle? The reason why I implement these as separate classes is to show you how easy it is to organize things into a different way. Use the class structure of Java in order to implement things very well. This is my paddle class. So in my paddle class, again, I create the paddle with a paint, and then specify the bounds of the paint with a rectangular F, and then the move size is 20. So this move size is a variable that I use in order to indicate every time I hit the key, how many pixels I need to move my paddle to the right or to the left. So every time I hit, what do? I move the paddle. This is where I set up the paddle. Okay? And so this is where I set the paddle's bounding points. And then if I say move right, so what I'm doing is I am updating x min and x max. Move right the paddle. And then move left, I will move the x min is the one end of the paddle, x max is the other end of the paddle. So I basically move to the right and the left by shifting those values. And so on, move left. And then drawing the paddle on the screen, I simply use canvas draw rectangle and then specify those values there, and that's how I paint the paddle on the screen. And so on. And then this is status message. This allows me to draw text onto the screen again. The procedure is same, similar principle creating this status message. Okay. And what's the box? This is the box, the outer bounding box that I draw onto the screen. And I set x min, x plus 1, and x max, x plus width minus 1, and height. Width and height, where do I get? I get here from these two variables. This is the initial point, and so the box value, I get it from the draw view when I create a box here. Where do I create a box? Okay, here. I create a box with a particular value here. Alright, so I specify the size of the box right here. So on size change tells me whenever the screen size changes. So this is where I set up the size of the box appropriately. So some minor adjustments. Okay. Again, I don't expect that you would have understood all the things that I show in the code right now. But what is your job to do? Go to the lab next week, run through the examples, not just simply type the things and then run through them, but instead go in and change the code, modify the code and see what happens on the screen. The computer is not going to blow up with an explosion in smoke if you change a few things. All that might happen is your application will not work. You can always change it back, right? That's how you learn. You try and learn by trial and error. Okay? So that is the use of 2D graphics canvas with a view. Now, This suffices if your application requires only minor short changes and not a whole lot of frame rate within your application. If you want high frame rate, then you should be using something called SurfaceView. What is SurfaceView? SurfaceView is a special subclass of view, again, another subclass of view, and this is what Android provides for you to implement 2D games. Three-dimensional games, three-dimensional things and so on are all implemented using OpenGL. Okay? 2D gaming, this is a specialized, customized 2D graphics library that Android provides. Okay? So this surface view offers a drawing surface to an application, and what you do is, in view, what did you see happening? In the view class, you did the onDraw method, and the onDraw method is implemented inside the view class. The onDraw method's code is directly executed on the UI thread. If it is directly executed on the UI thread, it's going to freeze the screen for short periods of time. But fortunately, that code is very short, and so you can get away with doing that on the UI thread. But normally, if you have a lot of complicated updating to the screen to be done, then what you do is you create a canvas and hand it over to a background thread, to a separate thread, and let that thread take care of doing the updates. And when that thread does the update, it will call back your system and hand over the updated canvas to be painted onto the screen, and then the thread will go back to redrawing the next version of the frame or next version of the canvas, and then keep it ready, and then when it is ready, it'll bring it back to you, and then you keep updating the screen. Whenever the background thread throws out a new updated version of the canvas onto you, you update the screen accordingly. Now for this, SurfaceView provides certain callback methods and things like that, which I'll show you in a minute, and that is how you do that. So this update of the surface view has to be done in a secondary thread. Okay? And this can be done at its own pace. It can do complex updates behind the scenes, and then when it is all done, then it comes back to update the screen. So that way you can do all these updates in the background, finish, and then come back to update the screen. Unfortunately, I have run out of time, so we'll examine this in the next class on Wednesday, and then on Thursday you will see it in the lab. Okay? So that is 2D graphics on SurfaceView introduction, and then we'll come back to
So there are more.
Wednesday.
There are more.
Okay.
咩？
That's it.
有冇留？
We're done for
係啊。
today.
一樣嘅，你做嘅。
We want more frequent updates to the screen and more stronger control on how frequently you update the screen. Then SurfaceView is a better way of handling this scenario. So what I have done is, in the example that I showed you last time, I showed you the example which had this ball moving on the screen. I was reading a book on Steve Jobs' life, and then I realized that there was a name to this game, and this was one of the first, a version of this game. This was one of the first video games called Pong, P-O-N-G. I don't know if you've heard of it. This is a one-dimensional Pong. Basically, in Pong, you have two paddles that two people would use to bounce the ball on the screen. This is a one-dimensional Pong because I have only one paddle. The other side was the walls that were bouncing things on the screen. And so it's a very interesting, very classic video game, one of the first video games apparently. I didn't know about it. I just thought I had seen something like this before, and then I implemented this particular game, and it turned out that this is a version of Pong. So anyway, filling in a little bit of history behind this game, or this example, which I didn't even know existed. So if you need to implement the same, so what I did was I went back and then re-implemented the same example using SurfaceView rather than View, just to show you that you can achieve the same behavior using two different methods. So in the lab tomorrow, you will get access to both these versions. You get the view version and the surface view version, and then you can play around with either one of them. Surface view is a bit more complicated to implement than the simple extending of view. In case you extend the view, the on-draw method of the view was the way you were controlling things on the screen. In surface view, which is a special subclass of view, what surface view does is it offers you with a dedicated drawing surface. And this drawing surface, which is a canvas, you do the updates offline in a separate background thread, and then you will be updating the screen in this case. So this drawing surface is offered to an application's secondary thread. So what this immediately means is that when you implement using surface view, you need a background thread, and you need to update the canvas with the background thread. In the view approach, you are updating the canvas directly in the on-draw method of the view class. So this is what you will see in the application implementation, same application implementation, which I'll show you in a minute. So the application, by implementing it this way, the application doesn't have to wait until the system's view hierarchy is ready to draw. Instead, the updates are done in the background, and then when it is ready, then the view hierarchy will be updated. So a secondary thread that has reference to the surface view can draw to the canvas at its own pace. And once it is completed reconstructing the canvas, then it will update the screen at that point. So in your code, you will take the surface view and then extend the surface view class. And when you do that, you need to implement surface holder callbacks. There are three methods that you have to implement within your code. For most purposes, you can simply have just stub code for a couple of them, and then it will still work fine. But some places you will need to implement the code specifically. These methods to be implemented are surface created, surface changed, and surface destroyed. These three methods have been implemented, and you will be handing over the canvas to a background thread, and you will be doing your updates in the background thread on the canvas, and then after that you will be updating the screen from there. Okay? So this is the way you handle surface view. So the surface object is handled by a surface holder. So if you need to get access to this surface, which is nothing but a canvas, you use the surface holder in order to get access to it. And I'll show you how to do that. And for the surface holder, you call this method called getHolder in order to get access to the surface holder. And then when the surface holder, you inform the surface holder saying you're going to handle all the callbacks by doing this. Then in the callback method, you will be updating these three things, these three methods. And then you will create a secondary thread that will control all the drawings to the surface. And you will pass the surface holder reference to that thread. And inside the thread, it will get hold of the canvas by saying surface holder lock canvas. Because you could, in principle, update the canvas from multiple threads if you want. So you could, for example, in a game, you could have different parts of the game logic being implemented by different threads, and all of them could be updating the same canvas at the same time. Okay, but in order to ensure that updates are done in a proper manner, you need to ensure that any changes that you make to the canvas are done inside a critical section. So you need to first lock, then do your updates, and then unlock. So that is how you ensure that all updates done by any particular thread is completely done before another thread gets notified and so on. So multiple threads could update the canvas. And when you're all done, you will call this method called a surface holder unlock canvas and post. And then at that point, the update will be delivered to the screen. Okay? So that is how you would handle 2D graphics. Now going back to the example that we saw last time, I will show you the surface view method of implementing the same game, and you would be surprised that the update is only in one single the draw view that you saw earlier, instead of it being a subclass of view, it will now be a subclass of surface view, and which also entails that you need to implement certain callback methods. So I will show you the code for both the view way of implementing things and the surface view way of implementing things, and then we will see it running on the screen. So going back to our let's see. The Eclipse, this was the one that you saw last time. Okay? In this is the main file where you implemented much of the functionality of the game. And then as you saw, you implemented this onDraw method. So this is the original draw view. And then you saw that the draw view was extending the view class. Now, the same application implemented using surface view, you would be implementing it by changing the draw view to make use of surface view instead. The remaining files here will be the same as before. I haven't changed them in any way. It's only the draw view that I have changed. So what I do here is that I extend surface view instead of the plain view. Okay? So this is how you would be making use of surface view. And also, you need to implement the surface holder callback methods inside this subclass. Okay? So after I subclass it, then in the constructor method, this is the constructor method for draw view, I get hold. Now when you do this, you need to pass two variables to the draw view, context and attribute set. Don't worry about what they are, you just need to pass them to the constructor class. And then in the constructor class, obviously, you would notice that anytime you have any of these constructors, you would be doing a super, so that you would be updating the parent class, and then pass those two parameters to that. And the first thing that you will do is you will do get hold of the surface holder, and then you add callbacks. This, which means that you have implemented the callbacks inside this class. And then after that, the rest of it is the same as before in the other class, as you would notice. Now here, you would notice that this code is very much the same as before. Okay? So not a whole lot of change in there. Now the reason I was able to do this change without too much of modification is that all those objects that I'm using to paint on the screen, I have declared them as separate classes, so all that I need to do was call them and then use them. So that construction, by separating them into classes, makes it very, very easy to modify the code. Okay? Now, inside here, previously, I had this method called as onDraw. Inside the onDraw method, I was updating all these things. So what I did with surface view is that I changed that method into this method called draw game board. This is just my name. Okay? There is no specific meaning to this name. It's just draw game board. Obviously, it makes sense to call it draw game board. And inside here, I have done exactly the same as painting things onto the screen. Okay? That's all I'm doing here. Okay? Furthermore, I have implemented two other methods called stop game, if I want to stop the game midway through or pause the game midway through. And then you can implement this method called release resources, which fortunately I don't have any resources to release in here, so I didn't have to implement anything there, so it's an empty set. This you have seen before, on size change. This is called whenever the size of the screen is changed because of rotation and so on. So it's straightforward. Now, and then This one also you saw earlier. So again, going back to the on draw, notice that this part is the same, which I have basically shifted this code to the draw game board method. These things I don't need this in that method, because there is a separate thread that is taking care of these things, so I don't need them, so I don't remove them and change the name. And you would notice that this is the key handlers that I have implemented. But in addition to that, I need to implement these three methods: on surface changed, on surface created, and on surface destroyed. Okay? On surface changed, I didn't know what to do with it, so I simply left it as a blank. Nothing to do there. But if you don't put it in there, Java or Android or Eclipse will complain, saying that there is missing. So that's why you need to put it there. Just put it blank stub there in place. Okay? Now for on surface created, when is this method called? This method is called immediately after the surface is first created. So in this method, you need to start a thread and then hand over the canvas to the thread, hand over the holder to the thread. Where is this holder? The holder is up here somewhere. So get holder. Okay. Okay. You simply call it with the variable holder, and then it knows where to get it from. And this holder is supplied by, this holder is supplied to the Android framework. The framework is the one that calls this particular method. Okay, so this holder is passed in as a parameter to this thread, and we will see how this thread handles this holder and so on. And then once I create the thread, I start the thread. Okay, I'm just using a variable in order to remind myself. This is a Boolean variable which reminds myself that the thread is up and running. So that's why I declare that. I'll show you the code for this particular method inside the thread class. So this is a method in the thread class. Now, and when the surface is destroyed, this is called when the application exits and when the surface is being destroyed. So in this case, you set the set running to false, and then you try to remove the thread that you have created. And so inside here, you're removing threads. So the surface destroyed is implemented using this simple code here. Now, the important part of this whole thing exists in here, in this method, in this class, which is the subclass of the thread. So this is the background thread that is handling the updates in the canvas. So what I am doing is, when you create the canvas, again, remember that when you create the canvas, you create a new thread, and then you start the thread in the surface created. Okay? Now, inside the thread class, I am declaring these things. So I am declaring a surface holder variable, and then when my constructor is called, when my draw view constructor is called, I am initializing that to the surface holder reference, so that I can make use of it inside the code. And this other method, set running, is simply used to set the code to be run. And most importantly, when you create a thread class, you need to implement the run method of the class. And the run method of the thread class is the one that is going to take care of what the thread is supposed to be doing. So inside the run method, what am I doing? Inside the run method, I get this variable canvas, and then I I get canvas is equal to surface folder. This is the folder reference that I got, and lock canvas. So I first lock my surface, okay, and then after that, in here, notice the use of the word synchronized here. So this ensures that I am accessing it inside a critical section, and then I am updating my. This method you have just seen implemented earlier, draw game board. This is the method that draws things to the canvas. So what I'm doing is I'm passing this canvas as a parameter, and the canvas will be updated by the draw game thread. So inside this thread, I am drawing everything on my canvas. And after I am done drawing, so this is the try catch exception. And then finally, after I am done, I will unlock canvas and post. When I do that, I am informing the framework saying I'm done. Post this onto the screen. Okay, so that's the job of this particular. Okay, as simple as that. It's not that difficult when you go through it step by step. It becomes very straightforward. All right. This is just one example of how you could make use of SurfaceView. So if you're implementing a bit of a complicated game, make use of SurfaceView in order to implement. Now, if I run this code, I already have the emulator up and running. Hopefully it should work here. So you can see that the game has been started. It's exactly the same. You don't see any difference in the screen, but it's exactly the same game. But now it is implemented using Surface Folder. And with Surface Folder, if you update it quite frequently, then the screen will be a lot more smoothly being done and so on. So in here, what I'm doing inside my thread is that in order to ensure that I am doing these updates only every 33 milliseconds, I make my thread sleep for 30 milliseconds. If I remove that, you will see the screen being updated very, very frequently. So your application will not move more frequently, and it will be updating the screen more frequently. Obviously, it will be consuming more battery resources. So that's something that we need to keep in mind. We will need more computation to be done. So in order to prevent it from, in this particular game, you don't need that many frequent upgrades to the screen, so it is good enough to be done this way. Okay, so again, the same game running up on the screen. And what I do is that if I hit the back button, now the back button works properly, stopping the game and going back to the back button. I can resume the game again if I want to by going back to the game until resume at the correct point. The reason why these things work is that together with this, I made minor changes in the main.java file where I implemented, along with the onCreate, I also implemented the onPause and the onDestroy methods. Okay? In the onPause method, when is the onPause method called? When your activity moves away from the screen, the onPause method is called. And in this case, I am basically, when the onPause method is called, I am stopping the game at the point so that I can resume when my activity comes back to the floor. So that's one more thing that I need to ensure that my application is done correctly. Okay? Straightforward, simple game implementation. So tomorrow in the lab, you will get to see this and implement it, play around with it, modify the code a little bit, make changes to it, run it, and experience doing this example. Okay? Any questions? Everybody comfortable so far? No problem. Okay, so that is for 2D. So 2D implemented in several different ways. Simple things like controlling layouts of things on the screen and the backgrounds and things like that. You can make use of the drawables. These are different kinds of drawables, which allow you to implement different kinds of things on the screen, static things. Then we saw animation. That's the second one, both view and property animation. And then the third thing that we saw was 2D, two-dimensional graphics. Now, the last one left over in this particular case is three-dimensional graphics. In 3D graphics, Android makes use of